question 6.3 of chapter 6. I wasn't aware that in one of my algebra classes I forgot to explain this. All right, so what this is this is an input-output table here. There's your x's, there's your y's. And so what we do is we do a rate of change, which is really slope. So use this ordered pair and this ordered pair to figure out the slope, we get -3. Then we use this ordered pair and this ordered pair, we get -3. We do it in -3. So we can see anytime we do rate of change and we get the same slope for all our pairs of ordered pairs, that means the equation is linear. You come over here, basically what we're doing is we're just taking our y's. We're taking the second y over the first y, second y over the first, second y over the first. See how they're all different? That tells us that it is not exponential. We come down here, and again we do the same thing. We have an input-output table, and so what we do is, we do our slope for each pair. We can see we get -16 and -8. We get a different one, so we know it's not linear. But over here, when we do 16 over 32, 8 over 16, we get the same ratio. So this tells us that it is exponential. So that's our two tests for ordered pairs. Now, an exponential equation is where x is in the exponent's position, and there's some number that's a base. So this is f of x equals 2 to the x power, or y equals 2 to the x. If we did an input-output table, we'd get these values here. And if we graph those values, we get a line that looked like this. And right here where it says y equals 0, red, it's called an asymptote. We'll talk about asymptotes in chapter 5. This is another exponential equation. This is where the base is a fraction or less than 1, still to the x power. And you can see what happens to the graph. There's the input-output table. There's the graph. The graph just flips. Okay? There's a problem where we're just doing the same thing we did before with our transformations. The -3 here tells us that we're going to shift it down 3. The negative in front of the x tells us it's a reflection across y. A reflection across y. So here's what's happening. So here's the normal graph, y equals 2 to the x power. Here's what happens when we go y to the 2 to the negative x power. You can see that what we've done is we've multiplied all our x's by a -1. So that the 3 here now becomes a -3, 2 becomes a -2, so on and so forth. All right? So then we come here and we shift everything down 3 with the -3. So we're subtracting 3 from all the y's. And incidentally, this example is on page 442 in your book. Understand with exponential notation, our number system is base 10, but in biological systems and physics systems and things like that, engineering, we have this base number e. Make sure you know that e is a number. It's like pi. If you come down here, you can see that e is equal to 2.71828. You can also see that on your calculator has two bases that the calculator works with. If I can get this focused in. I don't know if I can get this focused in, but if you look on your calculator, you'll see 10 to the x power and e to the x power. Come to solving exponential equations. Now these are example 7 and example 8 in your book. Here we have 3 to the x plus 1 power equals 81. Well, in order to solve exponential equations, we got to get them in the same base. So 81 is 3 to the 4th power. Once we have the same base, we can set our exponents equal, and we get x equals 3. All there is to it. Coming over here, we got 4 to the 2x minus 1 power, 8 to the x plus 3 power. So what we're going to do is make 4 2 to the 2 squared, which is still 4. Right here. We're going to make 8 2 to the 3rd power. Now remember, 2 squared, it has to multiply times 2x minus 1. 3 has to multiply times x plus 3. But we do have the same base, so now we can just write 2 times 2x minus 1 equals 3 times x plus 3. Distribute. Add the 2 over. Subtract the 3x over, we get x equals 11. Just remember that this is basically your power rule. So that what happens when we change 4 to 2 squared, that 2 multiplies times the exponent that was already there. Same with the 8. When we change 8 to 2 to the third power, that 3 multiplies times the exponent that's already there. Now, here's the tough one. This is to the e. Now remember, e is a number. It's a base number. It's 2.718, so on and so forth. So what happens here is, this one right here is already an e. What we do here is this is a power raised to a power, so we multiply and we get 2x. This, we're going to use the negative exponent rule, move this to the top, and it becomes e to the negative 3. We come down, and because e to the 2x is multiplying times e to the negative 3, we add these, so that's how we get e to the 2x minus 3. Notice we have e as a base on both sides, so we can set our exponents equal. Negative x squared equals 2x minus 3. What I did here was add the x squared over and then just flip sides. So it becomes x squared plus 2x minus 3 equals 0. X squared plus 2x minus 3 factors into x plus 3 times x minus 1. So there's factors equal to 0 solved. We get x equals negative 3, x equals 1.